So here we'll talk about homogeneous systems. So the first question, what is a homogeneous equation? Well, a homogeneous equation is any equation that can be written into the form a1x1 plus a2x2 all the way up to a n xn equal to 0. a1 through an are real numbers, and x1 through xn are variables. A homogeneous system is a linear system in which all equations are homogeneous. So the main idea here is that our constant values will always be 0. So an example of a homogeneous system, 2x1 plus 7x2 minus 8x3 equal to 0. x1 minus 4x2 plus 6x3 equal to 0. And 5x1 plus 2x2 plus 9x3 equal to 0. So this is an example of a homogeneous system, and we see that because all of the constant values right here are 0. So a homogeneous system always has a solution because the set of all zeros will always be a solution. And this is known as the trivial solution. So for example, when we see this system here, we'll notice that 2 times 0 plus 7 times 0 minus 8 times 0 is 0. 0 minus 4 times 0 plus 6 times 0 is 0. 5 times 0 plus 2 times 0 plus 9 times 0 is also equal to 0. And this will happen for all homogeneous systems. They will always have a trivial solution. So when we're dealing with these, our question is, do they have a non-trivial solution? Is there another possible solution? And if the answer is yes, then they will have infinitely many. It is impossible for a homogeneous system to be inconsistent. And in addition, this means that it will have a non-trivial solution if and only if the system contains free variables. So now let's consider this system. So we want to solve this to see if it has infinitely many solutions. We want to solve this to see if it has only the trivial solution or if it does have these non-trivial solutions. So we will put it in a matrix and row reduce. We have a 2, 3, 4, 8, 7, 6, minus 2, minus 3, minus 4, 0, 0, 0. When we row reduce this, the first step is to get a 1 in the first row, first column. We do this by multiplying the first row by 1/2. So that's a 1, 4, minus 1, 0. The second and third rows will be left alone for now. We now want to get the zeros underneath the 1. To do this, we will start by multiplying the first row by -3 and adding it to the second. So -3 plus 3 is 0. -12 plus 7 is -5. +3 minus 3 is 0. And 0 plus 0 is 0. To get the second one, we'll do -4, row 1, plus row 3. Negative 4 plus 4 is 0. Negative 16 plus 6 is negative 10. 4 minus 4 is 0, and 0 plus 0 is 0. Now that we have that, the next step would be to get a 1 in the second row, second column. So the first and the third rows will stay the same for now. And we'll do this by multiplying the second row by negative 1/5. That gives me 0, 1, 0, 0. We now need to get zeros above and below this 1. To get the first one, we'll do negative 4 times the second row plus the first row. That gives us 0 plus 1 is 1. Negative 4 plus 4 is 0. 0 minus 1 is negative 1. And 0 plus 0 is 0. To get the second one, we'll do 10 row 2 plus row 3. And you'll see that that gives zeros all the way across. So our equations are x1 plus 0x2 minus x3 is equal to 0. The second row just says x2 is equal to 0. And then the third row doesn't say anything at all. Our final solution, x1 is equal to x3. x2 is equal to 0. And x3 can be any value. So this one did have infinite solutions. It does have the trivial solution, in particular when x3 is equal to 0. And then it also has lots of other solutions.